This will be for the Kuta software worksheet, simplifying square roots. So let's go over some divisibility rules first. Okay, a number is divisible by 3 if the sum of its digits is divisible by 3. So, for example, if you take the number 87 and you want to know if that is divisible by 3, just add the individual digits, 8 plus 7, and that equals 15. Okay, and of course we know that 15 divided by 3 is just 5 with no remainder. Okay, if there's no remainder, when you add the digits and divide by 3, then you know the original number is divisible by 3. Okay, a number is divisible by 4 if its last 2 digits are divisible by 4. So let's say you have a large number. You can have 3,148, and you want to decide if it's divisible by 4. All you have to do is look at the last 2 digits. All right, the last 2 digits are 48, and we know that you can take 48 and divide it by 4, and you will get 12 with no remainder. So if you divide the last 2 digits by 4 and get no remainder, then the original number is divisible by 4. Okay, a number is divisible by 5 if it ends in a 0 or 5. Okay, pretty self-explanatory. So you can have a large number, okay, 1,480. You know that's divisible by 5 because it ends in a 0. You can have 2,835. You know that's divisible by 5 because it ends in a 5. Pretty self-explanatory. And finally, a number is divisible by 10 if it ends in a 0. Okay, so you can have 1,450. Okay, as long as the number ends in a 0, then it will be divisible by 10. Now for the square roots, we're going to be breaking them up into factors. Okay, and whenever you have 2 numbers multiplied by themselves inside the square root, you can cancel 2 of them and bring it to the outside. So let's say you have the square root of 2 times 2 times 3. Okay, you can cancel two of the 2's and bring that to the outside of the square root. So in this case, the simplest form would just be 2 radical 3. All right, one more example. Let's say under the square root, you had 3 times 3 times 3 times 4 times 4. Okay, so we can cancel 2 of the 3's and bring that to the outside, and we can cancel 2 of the 4's and bring that to the outside. Now these 2 numbers on the outside are going to be multiplied by each other. Okay, so you would do 4 times 3 and get 12, and underneath the square root there is still a 3 remaining. So if you bring more than one number outside of the square root, those numbers are going to be multiplied outside of the square root. Okay, let's look at number 1. We have the square root of 96. So basically what we want to do is write out the factors for 96. All right, and I know we went over divisibility by 4, but if it's an even number, of course you can always start with the number 2. So we're just writing out the factoring tree here. What times what is 96? I am going to start with 2 because I have an even number, and 96 divided by 2 is 48. Okay, so you want to break down the numbers until you get to the primes. Okay, we know that 2 is a prime because we can't break up the 2 anymore. It's just going to be 2 times 1. For the 48, we can do 6 times 8. For the 6, we can do 2 times 3. For the 8, we can do 4 times 2. And for the 4, we can do 2 times 2. Okay, and what you want to do is circle all the last numbers. So they should be primes. Actually, I'll show you in another one that might not have to always be primes, but just circle all of the last numbers that you didn't break up. Okay, so the square root of 96 is going to be the equivalent of these circled numbers multiplied. So we have a 2, we have a 2, a 3, a 2, 2, 3, 2, and then we have 2 times 2. Okay, so we got all of the numbers that we circled. And now, like in the intro, cancel out 2 at a time and bring it outside of the square root. So as far as 2 times 2, the square root of 2 times 2 is just 2. And again, the square root of 2 times 2 is just 2. So those are going to be multiplied. And then underneath the square root, we have 3 times 2. Okay, of course, 2 times 2 is 4. And 3 times 2 underneath the square root is just 6. Final answer, 4 radical 6. All right, I suggest you check your answers on pages 3 and 4. Okay, let's look at number 9. Now, some of these you might have to experiment a little bit on the calculator. We have the square root of 343. This is not an even number, so it is not going to be divisible by any of the even numbers, 2, 4, 6, 8, etc. Okay, so we can't use those. So let's see, is it divisible by 3? Well, let's see, if you add 3 plus 4 plus 3, that equals 10. Okay, and if you try to do 10 divided by 3, it does not divide evenly. Okay, you're going to get a remainder. So it's not divisible by 3 either. Okay, and again, we said no even numbers. Divisible by 5, it does not end in a 0 or a 5, so it's not divisible by 5. Let's see if it's divisible by 7. Okay, and I think you might as well just do this part on your calculator. Okay, divisible by 7. Let me see. 4 times 7 is 28. And that is 63. Bring down to 3. And 9 times 7 is 63. Okay, so 7 times 49 is going to give us 343. So that's going to be the start of my factoring tree. All right, so let's start the factoring tree with 7 times 49. So 343 is 7 times 49. And we know that 49 is 7 times 7. Okay, 7's a prime. We can't break up the 7s. So we're going to circle those. So 343 is the same as the square root of 7 times 7 times 7. Okay, so we can cancel 2 of the 7s. So we cancel 2 7s, you bring 1 to the outside, and we have 1 more 7 under the square root. Final answer, 7 radical 7. All right, let's look at number 13. We already have a 7 outside of the square root, so we're just looking to break up the 600. All right, so let's write out the factors for 600. And we know that's divisible by 100. 600 is the same as 6 times 100. And 6 is the same as 2 times 3. And 100 is the same as, well, I'll tell you what. I want to show you a little shortcut here. We'll leave the 100 as is. And the reason I can leave the 100 as is because I know the square root of 100 is just 10. Okay, and the 2 and the 3 we can't break up anymore. So I'll show you a trick here. All right, we already have a 7 on the outside, and underneath the square root, 600 is the same as 2 times 3 times 100. Okay, 2 times 3 times 100. Okay, now I can't take out the 2 or the 3, so we have the 7, and I know that the square root of 100 is just 10. So I am going to factor out a 10, okay, since the square root of 100 is 10. And underneath, I'm left with 2 times 3. Okay, so 7 times 10 is 70. And 2 times 3 underneath the square root is 6. So that is the final answer. And I was going to say, if you do your factoring tree and you get a number that you know the square root of, you can stop right there. You don't have to keep breaking it up, because it will be very easy to factor out or take the square root of that number. So like if you're doing the factoring tree and you get a 25, you can just leave that, because you know that 5 times 5 is 25. All right. Now, you could have kept going if you wanted to. If you wanted to break up the 100 into 10 and 10, and then break up the 10s into 5 and 2, you could have done that as well. And then you would have all these numbers underneath the square root symbol. Okay. And you would still get the same answer. So you can break it up all the way to the primes if you want, but if you have a number like 100 or 25 that you know the square root of, you can stop there if you like. All right, let's look at number 23. We have 1,215. Okay, that ends in a 5. So I know it's going to be divisible by 5. And really, I would just do this on the calculator. Okay. But I'll show you. Let's see. 2 times 5 is 10. Carry the 2. 4 times 5 is 20. Carry the 1. That's going to be 243. All right. And let's see. 2 plus 4 is 6, plus 3 is 9. So I know 243 is divisible by 3. And 8 times 3 is 24. 1 times 3 is 3. So this 243 is the same as 3 times 81. All right. And 81 is the same as 9 times 9. But remember, if I know the square root of 81 is 9, I might as well just leave it. Okay, so 5 times 3 times 81. Okay, we already have 11 outside of the square root. Inside the square root, I'm going to write 5 times 3 times 81. Okay, we still have the 11. The square root of 81 is 9. And we still have 5 times 3. Outside, 11 times 9 is 99. And inside the square root, 5 times 3 is 15. Final answer. Okay, and as I said before, if you wanted to break up the 81, you could have done 9 times 9. Okay, and instead of 81, you would have had 9 times 9. But still, it would have been the same thing. You cancel 2 9s, and then you bring 1 9 to the outside of the square root. So it would have been the same thing. All right, so just some quick hints. 200 is divisible by 100. 2,535 is divisible by 5. You can start by dividing by 5. 1764. I know 64 is divisible by 4. You can start with that. Or you can start by dividing by 2. It's an even number.